Welcome to Math with Mr. P. Today we'll be doing 6th grade math, chapter 2, lesson 5. We'll be comparing and ordering fractions, decimals, and percents. The main thing we're going to need to know in order to do this lesson is least common denominator. And the book defines least common denominator, or LCD, as the least common multiple of the denominators of two or more fractions. And the reason why we're going to do this is because we are going to be comparing fractions and making this easier on ourselves to be able to compare. So for example, if I have 1/2 and 3/4, the fractions cannot be compared as is because the denominators are different. Now, if you know how to split 1/2 and 3/4, you know that 3/4 is bigger than 1/2. However, there's another way of doing this. What we can do is convert one denominator or both denominators to be the same. In this case, we're going to change 1/2 to become a denominator of 4 because technically I could divide 4 by 2, but because that 3 is in the numerator, I cannot divide it by 2 and simplify it down any more than it already is. Therefore, the 1/2 is going to convert up. If I multiply 2 by 2, that will become 4, and 1 times 2 will become 2. Now it's easier to compare 2/4 to 3/4 because the denominator is the same. The only thing now we need to compare are the numerators because this fraction here, 2/4 is telling me I have 2 out of 4. 3/4 is telling me I have 3 out of 4. Which fraction is bigger? The one with 2 out of 4 or 3 out of 4? So this is the reason why we change our denominators and change the fractions, because this is going to make it easier for us to be able to compare. And not only that, we're actually ordering in this lesson. We're going to be putting fractions and decimals and percents in order from either least to greatest or greatest to least. We need to make sure we know how to convert all of these things into the same kind of format so we can do that. So, example number 1. We are comparing 5/8 to 7/12. This, again, as we talked about in class, is called an inequality, where we are going to either put in greater than, less than, or equal to make the statement true. We are going to be comparing 5/8 to 7/12. The book is asking us to tell them which one is bigger or if they are the same. I cannot do this with the denominators being like this. Therefore, we're going to change the denominators. Now, the book wants us to use the lowest common denominator. Again, this is going to go back to prime factorization and everything. However, you don't need to find the lowest common denominator in order to do this. You just need to find a denominator they both have in common. Once you change one or two of the fractions and you do it correctly, you should be able to compare the numerators easily. In this example, they're telling us that the 8 and the 12 can both be converted to 24. In order for 8 to become 24, it must be multiplied by 3. Therefore, I need to multiply the numerator by 3 as well, our numerator in this case being 5. So our new fraction is going to be 15 over 24. On the other side, 12 needs to be multiplied by 2 to become 24. Therefore, we'll be multiplying the numerator 7 by 2, which will make it 14. And that is our new fraction. Since 15 is bigger than 14, this makes it 5/8 is greater than 7/12, because remember, 5 over 24 is still 5/8. 14 over 24 is 7/12. These are going to be equal fractions. They just are in a different form. Therefore, our answer to this question is, from reading the left to right, 5/8 is greater than 7/12. We are going to do these 3 problems right down here, starting with 2/3 and 4/9. 2/3 compared to 4/9. Now, I know that I can easily change this 3 to become 9. So in this case, I'm only going to be changing the one fraction. I'm going to go ahead and multiply both of these by 3, because 3 times 3 will become 9. 2 times 3 will become 6. So now what I'm actually comparing is the 6 and the 4, because they're both over 9. Again, this is telling me I have 6 parts out of 9. This part's telling me I have 4 parts out of 9. 2/3, going back to the original problem, 2/3 is going to be greater than 4/9. And that's how I'm going to do this. Question B, 5/12. 5/12 in comparison to 7/8. So again, this goes back to the example we just had where we had a 5/8 and a 7/12. The lowest common denominator is going to be 24. Again, if you think of anything else that they both can go into, you can use that as well. But in this case, we're going to turn this into 24. Therefore, I'm going to multiply by 2 on this side. Multiply on 2 for the denominator as well, so this will become 10 out of 24. And on this side, I'm multiplying both of my numbers by 3. This will become 24, and our numerator will become 21. 21 is greater than 10, therefore, going back to our original problem, 5/12 is less than 7/8. And that would be our answer for that one. And our last example, 1/6 and 5/18. Now, I know that 6 goes into 18. I'm going to multiply 6 by 3 to make this 18. Remember, you don't have to change both fractions. If one fraction's denominator can become the other fraction's denominator, just change the 1. I do need to multiply this by 3, which will make this now 3/18. And 5/18 is clearly bigger than 3/18. Therefore, going back to our original problem, 1/6 is less than 5/18. Now they want us to order fractions from least to greatest. Now, in the last few examples, I erased the new fractions and went back to the original problem. We're going to be doing the exact same thing here. Even though we're going to be converting possibly all of these fractions to have the same denominator, we are actually going to be listing the original fractions from the problem in order for our answer. So, looking at 1/2, 9/14, 3/4, and 5/7. The least common denominator for all 4 is 28. Again, you can do this by writing out all the multiples of the number. You can do this by doing prime factorization and finding, lowest common multiple. You can also multiply all of them together, which I would not suggest. But as long as you can find a number that all of the fractions denominators can go into equally, you can convert all of these fractions. In this case, 2, 14, 4, and 7 will all go into 28. Therefore, they are going to change every single fraction to be out of 28. Starting with 1/2, we would need to multiply both numbers by 14. This would make 1/2 14/28. 9/14 would need to be multiplied by 2, because 14 goes into 28 2 times. This would become 18/28. 3/4 would be needed to multiply it by 7, which would make it 21/28. And last but not least, 5/7 would need to be multiplied by 4 to make it 20 over 28. Now, it's very important that we read the directions. They want us to sort this or order it from least to greatest. Now we're just going to look at each numerator. 14 out of 28 is my smallest number. That one is also equivalent to 1/2, so the first one is going to be 1/2 in that order. Next up would be 18 over 28, or 9/14 as it was originally. The next one would be 20 over 28, or originally 5/7. And our last one is 21 out of 28, which is right here, which was originally 3/4. So from least to greatest, the fractions should be 1/2, 9/14, 5/7, and 3/4. We are going to do this problem, and we have 4 fractions that we are ordering, and again, we're ordering them from least to greatest. It's very important that you read the problem because it could go from greatest to least, it could go from least to greatest, and if you didn't follow the directions and you put the wrong order, unfortunately, it will be marked wrong. So we are going to order 1/2. We're going to start on this whiteboard. 1/2. 5/6. 2/3. And 3/5. Now, I'm going to teach you guys a trick here. In order for my brain to work and see what number these 4 numbers can go into, I always pick the 2 biggest numbers and see if I can find a common multiple between the 2. 6 and 5 will both have 30 in common. If I multiply 6 by 5, it's 30. 3 can go into 30, and 2 also can go into 30. Now, this may or may not be the smallest common or the least common multiple, but it is a common multiple, and that's all that matters. If all of the numbers, all of the denominators can go into a certain number, you're going to have equivalent fractions that you can compare. Therefore, I'm going to turn every single one of these denominators into 30. I'm going to space these out a little bit more so I can show you the work that I did. 1/2, 5/6, 2/3, and 3/5. Now, I want them all to be out of 30. I'm going to use different colors for each fraction. Now, for 2 to become 30, I'm going to need to multiply it by 15, which means the numerator will also be multiplied by 15. 1 times 15 will be 15. So my new fraction is 15 out of 30 for this one. 6 needs to be multiplied by 5 to become 30, which means that I will be multiplying the numerator by 5. 5 times 5 will make this 25. So this will be 25 out of 30. 3 will need to be multiplied by 10 to make it 30. 2 will also be multiplied by 10, making this 20 out of 30. And last but not least, my 5 will need to be multiplied by 6 to make it 30, which will also be what I will be multiplying my 3 by to make this 18 out of 30. Now, the question asked me to rank them from least to greatest. Now, notice how I wrote the new fractions next to the original fractions. I'm going to list the original fractions in the order from least to greatest, not the new ones. My answer is going to need to be in the original fractions the question gave me. Now, out of the 4 numbers, I'm just looking at the new fractions. 15 out of 30, 25 out of 30, 20 out of 30, 18 out of 30. The least or the lowest one is 15, which means from least to greatest, 1/2 will be the smallest out of the 4. I can cross that one off and I'm done. Next would be 18 out of 30, or the original fraction was 3/5. Then I'm going to have 20 out of 30, or the original fraction was 2/3. And last but not least, 25 out of 30, or 5/6. So from least to greatest, I have 1/2, 3/5, 2/3, and 5/6, and that is my answer. Now we're going to be comparing fractions, decimals, and percents. Now, last week I made you guys write in your book some easy conversions. You can also find that on Teams if you did not write it in your notebook. Again, 1/4 or 1/4 is a quarter, 0.25 as a decimal, 25% as a percent, 1/2, 0.5 or 50%, 3/4, 0.75 or 75%, 1/3, 0.3 with the bar notation if you want to be specific, or 33%. 1/5 is 0.2 or 20%, and then 1/10, 0.1 or 10%. Again, this is on Teams, or you can pause the video and write those down. We are going to be comparing even more. So this page right here, this is on page 131. I would highly suggest copying this down as well, because these are going to be some of the newer fractions that I haven't had in there. 1/3 being the only repeat here. 1/5 also. Okay, so 2 repeats. 1/8, 0.125 or 12.5%. 2/5, 0.4 or 40%. 3/8, 0.375 or 37.5%, and so on. These are going to be some good ones that you're going to want to have in your notebook. So either you can cut this out of your textbook and tape it into your notebook, or copy this down into your notebook. And I would definitely put this together with what you have on Teams and make it on one page. So if you need to rewrite it, go ahead and do that. Now we're going to be comparing 3/4 to 7 or 0.7. So this chapter is going to be doing a lot of these comparing different types of numbers, a decimal compared to a fraction. Now, in your quick conversion chart that I gave you, you should know that 3/4 or 3/4 is the same thing as 0.75. And we talked about this last week with money, 75 cents. So that one's an easy conversion. And it will be comparing 0.75 to 0.7. Remember, decimals can add zeros to the end. We can annex a 0. So it's like comparing 75 to 70. 75 is greater than 70. Therefore, going back to the original problem, 3/4 is greater than 0.7. Now, if we don't know our easy conversions, or it is a fraction that we are not familiar with, again, in order to convert a fraction to a decimal, there are a few ways. Number one, you turn the numerator into 10, 100, 1,000, 10,000, 100,000, and so on. And then you just put the numerator in that place value and make it a decimal. Or you can do numerator divided by denominator. As we talked about, a fraction is just a division problem that has not been solved yet. We will do this example for 3/4. If I divide 3 by 4, I will get 0.75. 4 will not go into 3. We put a 0. And since I have nothing else to work with, we put a decimal so I can annex a 0. 4 will go into 37 times, which will be 28. When I am done subtracting, I will have 2 left over. 4 cannot go into 2. Bring down another 0. 4 will go into 25 times. I will have nothing left over, 0.75. Example number 4. Lucida made 85% of her free throws. Henry made 7/8 of his free throws. Who has the better average? Explain. Now, last example, I turned a fraction into a decimal. You can turn a decimal into a fraction if you'd like. Again, you're going to need to have both fractions have the same denominator to compare them. It's just easier to turn a fraction into a decimal and then compare, or turn both numbers into decimals and compare in this case. This one's going to be a lot easier if we turn both into decimals. So 85% compared to, we'll do a new page. 85% is being compared to 7/8. Now we know based on the last lessons, percent to decimals, again, think of it like a letter line. From P for percent to D for decimal, we're jumping 2 times to the left. So the decimal ends up right here at the end since it's a whole number. Jump 1, 2. This will now become 0.85. I'm going to leave this original one here, but I'm going to say that this is also the same, 0.85. 7/8 is going to be the same thing as saying 7 divided by 8. 8 cannot go into 7. We need to put a decimal and bring down a 0. Now, 8 can go into 70, and then this is where you're going to need to know your 8/8s, and I told you guys I am terrible with my 8s, so I'm going to work backwards. I know that 8 times 8 is 64, and I know if I add 8 more to it, definitely going to be over 70. So that's where my mental math comes into play. It's going to go in 8 times. That is going to be 64. When I subtract, that will give me 6 left over. 8 cannot go into 6, bring it down to 0. And then again, mental math, I know that 8 times 5 is 40, which means 8 times 6 is 48. 8 times 7 will be 8 more, so that'll be 56, and that's where I'm going to stop. So 8, 7, 56. When I subtract, I'll get 4 left over once I borrow here. And then 8 will not go into 4, bring down a 0. 8 goes into 40 5 times. Therefore, this actually becomes 0.875. There we go. When comparing the two, I can add a 0 here. This becomes 850, 875. Technically, 875 is the larger number. Therefore, going back to our original problem, 7/8 is greater than 85%. Or, from reading from left to right, 85% is less than 7/8. But this was a word problem, so this deserves a word answer. Now, we're going to be doing a lot of these comparisons between decimals and fractions. We'll do a few of these. Let's do E, let's do G, and then let's do I. So with E, 2/3 being compared to 0.6. 2 divided by 3 give me 0. 3 goes into 26 times. That'll be 18. When I subtract, I'll get 2. 3 can't go in it again, and this will be 6, 6, 6, 6, 6 forever. So this is going to be a little bar notation. In this case, because it's technically 0.6666666 forever and ever, and this is just 0.6, this one is bigger. Therefore, 2/3 is greater than 0.6 if it'll let me draw on the whiteboard. There we go. For G, 1/5 and 0.2. Again, we can always refer back to our charts. 1/5 is 0.2. If I were to do this the long way, 1 divided by 5. 5 cannot go into 1. put a decimal, bring down a 0. 5 goes into 10 twice. That'll be 10. It's 0.2. So in this case, these are both equal. 1/5 is 0.2. Therefore, they are equal. And then in I, we have 7% compared to 7/10. Now, this one is an easy one where you can actually convert the 7 over 10 to become a percentage. Remember, all percents are out of 100. So if I need to change that decimal to have a denominator out of 100, 10 times 10 will make this 100. If I multiply that by 10, I have to multiply the top by 10. This is 70 out of 100, or in percentages, 70%. 70% is way bigger than 7%. Therefore, 7% is less than 7/10. So again, you do not need to always convert them into decimals. You can, if there's an easy method, change it to the exact same type of number. It depends on how your brain works, but I told you guys earlier, it's a lot easier to do it into decimals. It is. In this case, this is one of those rare moments where I could easily turn that into a percentage just by annexing zeros. Okay, the table shows the school carnival attendance. Which grade has the greatest part of the class attending the carnival? 6th grade has 5/8 of the class showing up. 7th grade has 0.5 of the class showing up as a decimal. And 8th grade has 58.3% showing up. Graph the numbers on a number line. Now, they've already graphed it for us in this example. They figured out that 5/8 is 0.625. If you divide 5 by 8, you get 0.625. Therefore, 6th grade is graphed right here on the number line. 7th grade is 0.5, and it's going to be graphed right here on the number line. And 8th grade is 58.3% right here on the number line. Therefore, 6th grade has the largest part of their class attending the carnival, and 7th grade actually has the least amount of students showing up for the carnival. And then again, they did this by turning all of these into decimals because, again, it is really simple to do this. If you were to convert 0.5 into a fraction, it would be 5/10. Then converting this into a fraction is going to make your head hurt. You would end up having to change every fraction to have a denominator of 1,000. It would be a lot more work than just converting them into decimals. So this one's already a decimal. Percent to a decimal would just have 2 jumps, giving you the 0.583, and then 5/8 just needs to be 5 divided by 8 to give you the decimal, and then you can compare all three, meaning 6th grade had the largest amount of students show up. This will be our last example, starting with lesson 7. We are going to be talking about percent of a number, and then we're going to go heavily into ordering other types of numbers together, comparing basically fractions, decimals, and percentages and putting them in order from least to greatest. Hiroshi found that 3/5 of his class prefers vanilla ice cream, 26% prefers chocolate, and 0.4 prefers strawberry. Which kind of ice cream do students prefer the least? So it's very important that we read all the way through. Which kind of ice cream do students prefer the least? Therefore, we are comparing these three and finding out which one is the smaller of the three numbers. Again, a lot easier to change numbers to decimals than it is to any of the other types. So the 0.14, which is strawberry, is going to stay there. 3/5 and 26%. 3/5, which represents vanilla, so I'm going to put a V underneath here for vanilla, and 26%, which is chocolate. And I'm going to write down here in another color that strawberry is 0.4. 0.14 with an S next to it for strawberry. We are going to convert these into decimals in order to compare which one is the smallest. Now, the percentage is going to be the easiest one to convert. So again, percent, the decimal, if there's no decimal in our percent already, it's a whole number, it goes at the end. Jump that thing twice to the left, because remember, for P for percent to decimal on a letter line, we are going backwards and we're going to the left. Therefore, from percent to decimal, it'll jump twice to the left, making this 0.26 for chocolate. So right now, chocolate is eliminated because chocolate is not the least. Chocolate is bigger than strawberry, so right now strawberry is in the running. It depends on what happens with vanilla over here. In order to convert 3/5 into a decimal, I can do 3 divided by 5, or I can take the easier approach and to make that denominator out of 10, 100, 1,000, so on. 5 can easily become 10 by multiplying it by 2. When I do this, 3 will become 6, and our denominator is 10. 6/10 is also the same thing as saying 0.6 because the 6 is in the 10th spot. 0.6 compared to the others, if I need to annex a 0, is 60 compared to the 26 compared to the 14. Vanilla is out. Our winner for the flavor that students preferred the least is strawberry. And again, a word problem deserves a word answer, so it would be something like Hiroshi's class. Let's see. Students in Hiroshi's class prefer strawberry ice cream the least. And there's your answer. So as always, if you have any questions, come to class with those questions written down so we can go over them. If you're not in my class, the comment section is there for you. I can get back to you as soon as I can. Again, this has been Chapter 2, Lesson 5, 6th grade math, and I will catch you guys on the next one.